Lesson 143, equally and unequally likely. So yesterday we spent some time learning about mathematical or theoretical probability. So looking at certain events and their outcomes and being able to predict the chance or the likelihood of a certain outcome occurring. So we looked at things like flipping coins, and we used the example of probability of flipping heads on a coin was 1 out of 2. There are 2 different outcomes. Heads is one of the outcomes, so the probability is 1 out of 2 or 1/2. And then we used that theoretical probability to predict how many times heads would occur if you flipped a coin 30 times. So you could assume, based on the theoretical probability, that if you flipped a coin 30 times, 15 of those times you would get heads. And then at the end of your lesson, you performed an experiment like this, either with a pattern stick, or I suggested doing it with a coin if you didn't have a pattern stick. And you came up with something that perhaps looked a little bit like this, where you flipped your coin or your pattern stick, and you may have noticed that you didn't end up with exactly 15 out of 30 times your outcome occurring. So here I gave you the example of if you flipped a coin 30 times, 12 of the times it was heads and 18 of the times it was tails. This is called experimental probability. An experimental probability just means the number of times an event actually occurred in a number of trials. So the theoretical is just thinking about the general probability of something happening, what's the likelihood of it happening, but then experimental is what actually happened when you tested it out. And you may have noticed, if any of you got actually 15 out of 30, let me know. I'd be interested to know that. But you could have ended up with a table that looks a little bit like mine, where you ended up with 12 heads and 18 tails or any other number. So it's not necessarily when you do the experiment that it's going to end up exactly matching your theoretical probability. And if you do some thinking about that, that makes sense. So let's say you decided to flip a coin once, and you ended up with heads. And then you said to yourself, oh, I ended up with heads when I flipped that coin once. The probability of heads must be 100%. Well, no, the probability is not actually 100%. You'd have to do a lot more trials to get to that accurate information. So the more trials you do, the more your result will match your theoretical probability. But for today, just know experimental probability, that's what actually happened when you tested it out. All right, moving on to things that are equally likely. All of our examples so far have been using scenarios that are equally likely, which just means all of the outcomes have the same mathematical probability. So if you look at this spinner here, the probability of spinning blue is 1 out of 4. We have 1 blue section out of 4, and all of those sections are equal. And the probability of green is also 1 out of 4, and the same for yellow and the same for red. All of our outcomes have a mathematical or theoretical probability of 1 out of 4. So all of those events are equally likely to occur. Same for using dice or number cubes. The probability of rolling a 6 is 1 out of 6. There's one side that has a 6 out of 6 total. Same for all the other sides. The probability of rolling a 5 is 1 out of 6, etc. for all the other sides. Same thing for flipping a coin. Probability for heads is 1/2, and the probability for tails, oops, an extra L, is also 1/2. Okay, so these are scenarios where all of your outcomes have the same mathematical probability. They're all equally likely. Now you can come to some scenarios where things are unequally likely. So if you look at this spinner, for instance, you will notice that some colors have more sections than others. So for instance, for purple, we have 3 purple sections out of 8 total sections. For red, there are only 2, so it's 2 out of 8. For yellow, also 2 out of 8. And blue, there's only 1 section out of 8. So the most likely outcome for you to spin would be a purple, and the least likely outcome would be a blue, because you have unequally likely outcomes. Now, the red and the yellow are both 2/8, so you could say that those would be equally likely. It's the same chance of spinning a red as it is a yellow. So just to be aware of, there are examples where you have unequally likely outcomes. And it can also work on spinners that look like this. They look very equal, but if you're looking for certain outcomes, they can become unequally likely. So for instance, the probability of spinning blue is 1 out of 4. But if you're looking at the probability of spinning a color that is not blue, the probability is 3 out of 4. So another example of unequally likely. It is more likely to spin a color that is not blue than it is to spin a color that is blue. So just be aware that there can be unequally likely probabilities depending on what you're looking at. And then one last thing for today, if we were in class together, we would play the fair or unfair games that are at the bottom of page 308. I didn't put them on your list of things to do for today, but it would be good and kind of fun to perform those experiments, to play those games. You will need more than one player. I think for one of them you need 3 players, for one of them you need 2. So see if you can have some family members, if they're willing, perform those experiments, play those games with you to explore this a little bit more. And that is it for today. So finishing your exercises, and then if you can, get some other players to play these games as well.